Hello again, Precalculus. Here's the final problem of 10-1, Day 1 notes. So maybe to escape the quarantine, you went camping, so now you're living in the middle of the woods off the grid. Maybe you're sleeping on an air mattress in a tent, but then maybe you're now once the quarantine is eventually lifted, you're going to have to deflate that air mattress. And so I have just the problem for you. So exciting. All right, so you have a vacuum pump. Let's not figure out where you're getting the electricity from. Maybe you have some kind of solar powered generator. Let's just go with that. And so now you're going to use that pump. Every time the pump pumps or the piston runs, you'll remove 15% of the air from that air mattress. You're going to start with 20 liters of air. So we're going to write 3 terms of that sequence after each pump of the piston. We will then review both explicit and recursive rules, and we'll review converging and diverging. So a cool little word problem. You will definitely see lots of word problems in Chapter 10, and that's what makes it fun and exciting, and I know you're going to love it. All right, so now the key thing here, though, the 15% is how much air is getting removed. However, the problem is asking how much air remains in the air mattress, and so this is great because we get to go back to exponential decay from Chapter 3, which we just finished, and everybody worked so hard to do their notes and homework and quizzes and get all those things done. Maybe you worked hard, maybe you didn't. All right, now, so if it's removing 15%, we care how much remains, so 100% minus 15% is 85%, so 85% remains. So let's find some terms. Obviously, we're starting with 20 liters of air. So now, after one pump of the piston, it's removing 15%, which means 85% of the air remains. And so grab your calculator, and that gives us 17 liters of air. I don't know how you measure air. I guess I'm using liters today. So now your second pump. Now remember, after the first pump, now there's only 17 liters, and after the second pump, it's taking another 15% out, leaving 85% in. You're going to want a calculator for that one. So after 2 pumps, 14.45. Let's go orange. So now after 3 pumps, we have 14.45 times another 85% remaining. I'm going to round this one, 12.283 liters. All right, both explicit and recursive. In my opinion, recursive is easier. So I always like to do the easier things first, work my way up. I said recursive, so let's pretend I can spell. All right, so now we've seen so many examples. This is getting too easy, but let's still go through it. So I need the first term. Well, my first term was 17, right, which we wrote in green, so I probably should have used green. Too late now. I'm not going back. Now we need a rule to get the next term. So I have to go back up. What was I doing every time? Times 0.85 times 0.85 times 0.85. And so I'm going to go 0.85 times the previous term, and a sub n minus 1 is the previous term. So there's the recursive rule. Let's do the explicit. So for our explicit rule, I'm going to use a sub n. Oh, I keep using the same color. Sorry, too late now. I'm not going to change it. So I'm going to go with the 20 liters of air that I'm starting with, just like we would have done in Chapter 3, times 0.85, raised up to the number of strokes or pumps of the piston. So I can input 1, 2, 3, 4, 5 to get out those terms. And since a couple ways you can make this final connection, we've realized that it's exponential decay from Chapter 3. You know exponential decay is going to take that shape right there. So we know there's that horizontal asymptote. We can see the values, as I looked right here, are getting closer and closer and closer to 0. Eventually we'll get close to 0 liters of air, so it is diverging. All right, I hope you're staying sane. Do your math, have some fun, and just make the most of these days. Hopefully the weather cooperates. We miss you guys. Have a great day. Bye-bye.